Okay, so we have some entertainment tonight. This should prove interesting.
This evening, I'd like to do a presentation with slides and also with some flight simulation, which is the topic of my presentation. Next. With flight simulation, it's essentially I wanted to break it down into what flight simulators are currently available. And in the world there's 3 different types, there may be 4, but for what I could see is there are FAA and European Aviation Safety Administration have approved flight simulators that are used for commercial air transport pilot training. They're very expensive. They're in millions of dollars. And they have 6 degrees of freedom on some of these, along with a surround 180-degree display for a pilot to view around the projected image. The second flight simulator I found was rear-controlled model aircraft flight simulators, and that covers real flight, which probably most of the RC pilots are using, Aerofly, Phoenix, and Picasim. They're cost-wise, they're about $150 to $200 in that range, and they're very good for rear control, training to fly rear-controlled model aircraft at different locations or fields, and then using that training to be able to maneuver aircraft as far as takeoff, climbing, doing certain maneuvers, be it 3D aerobatic maneuvers, loops, rolls, spins, and then safely doing a landing on the same field under control without crashing. Some of these simulators do have damage where if you do hit the ground too hard or an object, it'll essentially come apart. The third flight simulator that a lot of people have been familiar with is the full-scale flight simulators, and the biggest one was throughout the world was the Microsoft flight simulator. Microsoft considered it to be a game, but they employed maybe 50 to 100 developers over a period of I think 32 or 34 years. And as a matter of fact, they came out when IBM created the personal computer, and Microsoft was there, and their first game was Microsoft FS. I think 6 or 7 years ago, Microsoft dropped the flight simulator because they couldn't reach certain goals that they wanted from a business standpoint. So they let go of it. It was the Aces game studio, and I think they had 50 developers at the time. So they let them go, and quite a few of them went over to Lockheed Martin. Lockheed Martin got the intellectual property from Microsoft to use their, I think it was EFS version, and so their developers have created something called Prepare 3D, or Prepared, and it's running, to buy it is about $200, although they have a lower cost versions for schools. for STEM education. The third game company called Dovetail in the UK actually got permission from Microsoft licensing to license and come out with a flight simulator based on the software engine that drives Microsoft FS. And that should be out sometime this year. The next simulator is made by ProFlight Simulator, and in fact I just found this out this week. They're selling it for about $200, but they have an introductory price now for like $97 that you can go online and purchase it. And they essentially have, I think, 100 or 150 aircraft, full-size aircraft. And they provide scenery, the ability to change the weather conditions, the time of day. I think it'll do well. But the final flight simulator that I've been using since 2001 is Laminar Research's XPlane. Laminar Research is in Southern California. And the last one here is the one I'm going to talk about tonight as far as what it is, what it can do, and it also has more features than ProFlight or Microsoft FS, and it uses real-world physics to simulate lift, drag, and pitch moment, or moment of inertia on lifting surfaces, wings. Next. Okay, the XPlane Flight Simulator is the world's most comprehensive and powerful flight simulator for personal computers. And it offers the most realistic flight model available. XPlane is not a game, it's an engineering tool that can be used to predict the flying qualities or handling and performance of fixed and rotary wing aircraft with incredible accuracy. There are certain companies and governmental agencies that are using XPlane. NASA has used it. Scaled Composites, when Burka was there, it was used to help develop Spaceship One and the other aircraft that actually took it up. And I mean, I could do a lot. I could say a lot more about all the different companies. There are aircraft developers now that are using XPlane to do modeling before they even make actually build an aircraft, and they're doing it for fixed wing, rotary wing, for drones, or I should say small UAS and UAS models. So for me, the flight control characteristics. Essentially, my specialty is making these 3D models in XPlane fly as realistic as I possibly can, based on research that I've gathered. Next. Okay, what are some of the features? XPlane can simulate anything that flies. It can do fixed wing, rotary wing, helicopters, blimps, birds, you name it. You can model it. If you can model it, it'll use then real-world physics to essentially get it up in the air. XPlane simulates dynamic properties of the lifting surface using blade element theory. When you're saying to yourself, what is blade element theory? If you take a lifting surface like a wing and you start cutting it up like a loaf of bread, XPlane will take each slice and compute the lift, drag, and pitch moment for that section of the wing. And it does this very fast through every slice of the wing. It can be the main wing, the horizontal, or the vertical in the tail of those wings there. And it handles both symmetrical and semi-symmetrical wings. And based on that, it then sums the total lift, drag, and pitch moment for that wing, and then based on the center of gravity and the mass of the center of mass of the plane, it will then take the static computations and then actually as there's a propulsion system that will move it, or if you drop it off of a slope, airspeed will pick up, it'll start calculating, and it's fairly accurate as far as the motion dynamics.
Does it take the fuselage into account as well? With the same kind of...
From the lift, drag? Drag, yes. Drag, yes. Yes. And most of the drag there is the wetted surfaces of the fuselage. Like if you drop the gears down, it'll take that as drag. It'll take the funnel as the airflow is flowing in front of the nose. It'll take that as drag. For most jet engines, being a high bypass, most of that, the majority of those airflow will go through the engine. So there's not a lot of drag there. Any other questions?
How do you model your airplane?
The ones I have right now? Or the ones I've done?
Yeah, how would you model it? Do you use a CAD system, and how do you import it?
Well, no. XPlane has two internal programs called Filmmaker and Airfoil Maker. I use both, and essentially I do my research. I find out what real plane is available out there that I want to create. And then I'll look at photographs, I'll look at video, I'll look at the manufacturer's technical specifications. And then I'll use Filmmaker to start developing 3D structures. And, excuse me. And then start placing the wings, the tail, the landing gear. And once I've got that all set up, before I even paint it, I make sure that it can, and there's enough propulsion and in the motors or engines or jets or whatever, rockets. And I make it as real as I can, and then I fly. I do a lot of flight testing. Because there's so many things that you can change in Filmmaker. And then based on the performance that I see, can it meet the stall speed of that particular aircraft? And other maneuvers that I'm doing in the technical specifications, I then try to improve the performance of the aircraft so that if there's, say it doesn't have enough lift, then I'll go to Airfoil Maker and I can make the change in the lift line, the amount of drag for those wings, and also the pitching moment. And it can be for both the wings and the propellers. So these together in combination will create as real a plane as, and I've done over 80 aircraft.
Right, but how do you draw it? Or how do you input the shape of something? How do you start?
Yeah, so essentially a lot of aircraft are symmetrical. If you take a fuselage and if you only do half of the fuselage, then the other half is essentially a mirror image.
So
if you go to
there's
a
a
wing,
CAD system built into this XPlane that you can
Yes.
actually design
Remake, right
a
here.
3D model, right?
Yes.
That's
Now you can, well, I've been doing a lot of first generation. Second generation is where payware, in other words, those developers that do this full time and create a business out of it, they will use a 3D CAD program, like Blender or Maya or any of the others. They'll essentially create those, some of them go ahead and they scan the entire plane, wings, fuselage, inside, outside, and then they bring it into a 3D CAD and they make it as clean as they can. And then they bring that, they export it to XPlane, and XPlane into PlaneMaker. You still need that's the 3D shell. So the 3D shell comes in, and it looks like the real thing. But you need to still build a 2D flight model inside of that 3D shell. Once we do that, as a matter of fact, one of the planes, a couple of the planes I have, or they've done one or two planes. So this essentially, you do need a 2D flight model aircraft inside this 3D shell for both the wings, the fuselage, the engines, and the landing gear. Does that answer your question?
No, another question.
You got to see how it's done.
Another question.
Yes.
Can you invent your own airplane in this?
Yes. And I have. As a matter of fact, it was the very first one. The developer of XPlane worked for a company called DuPont, and the CEO, or the head engineer, CEO, whatever, his name was Tony DuPont. Tony DuPont was working with the Department of Defense. And at that time, this was when Ronald Reagan was around, the president. Ronald Reagan wanted a strategic plane to fly from America to Russia for that's both subsonic, transonic, supersonic, and hypersonic. It could get from here to Russia in 2 hours, or less than 2 hours. So they were going to develop it. The problem is, going at those speeds, the whole body and the wings get quite hot. So the technology wasn't there to keep the plane cold, because once it starts getting hot, materials start to essentially erode away, just like the spacecraft coming down from high Earth orbit. So what the developer, his name is Austin Meyer, he actually, in his flight simulator, he actually drew or designed the plane, put it in there, and that was the first plane I worked on with PlaneMaker and Airfoil Maker. It's considered a military aircraft, and with that plane, it has it's a delta wing. It looks a lot like the Concorde. It's very tall with the landing gear. With the delta wing, the Concorde had engines underneath the wing. The engines, there are 4 engines in the back of this. It's called the X-30, National Aerospace Plane. So the developer put 4 engines in the back of the fuselage, so it was big enough to carry 4 engines, each one 100,000 pounds of thrust. Now that's not too bad, because the Airbus 388 produces 80,000 pounds of thrust. But these engines are a little bit smaller, and they're called scramjet. So we have 4 scramjet engines, and then above those 4 are 2 small rocket motors, also 100,000 pounds of thrust. Initially, I went to fly it. It was very unstable, so I did some modifications to the stock plane in XPlane, and I did a lot of flight testing. Came down, did a second version, more flight testing, and then at that time I was part of a virtual airline. I actually joined 2. The first one I got out, didn't like it, went to the second one, called California Airlines. And the owner said, build it, and we'll use it, our pilots will use it. So he also built, the owner of the virtual airline, built the Concorde. So I said, do you want to race? And he said, no. And I said, look, one of our best pilots, I'll have him fly. You can put me into a bank vault, you can tie my hands up, put blindfold on me, and I'll still beat the Concorde. And it did. So, normally I'll take it up and I'll go past Mach 2, which is what the Concorde does, and I'll climb up to 100,000 feet. At 100,000 feet cruise, you can see the curvature of the Earth, and you can see black sky and the stars up there. And generally it likes to be at Mach 10, so I keep it at Mach 10. As I start to climb, if I want to climb higher to 200,000, I'll go to Mach 20, 300, Mach 30. I actually did one flight online from London Heathrow to Sydney, Australia. Flight time, 20 minutes. I tried to push it as high as I could, which was about 375,000, because at 400,000, this simulator will essentially take the plane and would be uncontrollable. So I kept it down, and I pushed it to Mach 64, 44,480. Now, you would think that the plane is going so fast, it's going to go, you know, it's going to just keep climbing. This one didn't. It's a full load to keep it under control. I had the wings vertical, and I had to keep it nose down because you don't want it to skip off. And as I landed the plane under air traffic control, above 60,000 feet, above that is Class G airspace. And essentially, you can do anything you want. A lot of military planes go up there, and also spacecraft. So as I came down, landed safely, went to the gate, the supervisor that could have kicked me off the online network, he said, did you build this plane? And I said, yes. He said, where can I download this plane? So that was my first one. I still have it. It's very smooth. It's actually more stable than the Concorde. Okay, let's get back to this. Any other questions?
I have a
Go ahead.
question. I don't understand.
By the way, before you, this simulator can be used by students in the STEM program.
Yeah, I wouldn't know the first thing how to use it, but I have a question here. When you say you flew it, were you physically flying it, or were you flying for software?
This is
or
virtual.
Virtual. It's all virtual, okay.
Right.
Here's a joystick over here.
How much fuel does it simulate to for that?
Every plane has a specific fuel consumption rate. So you can adjust the rate for the amount of fuel burned over time. And as far as the amount of thrust that the engine is producing.
So
How much you can carry?
in the simulator, does it bypass that so you can have unlimited fuel, or do you?
Yeah, I could. The other thing is this plane will not create any supersonic booms. How? Normally, when the wing is flying above Mach 1, it'll create a boom. So this plane will ionize on the wings and the nose, and any surface it comes to where it makes contact. There's either microwave or laser or electric field that ionizes the air in front of it, maybe a foot away. As a matter of fact, this is the same thing, Kyle, that we had a professor here who had these very small, sharp, and at high voltage, 3,000 to 4,000 volts, and they had another one here. So this is charged positive, air flows, and it wants to look for negative charges, which is another point that has to ground. So it flows and it pulls the ionized air molecule across. And if you have a number of rows, you can actually keep it laminar all the way past. The same thing with this. If you can take the air that's coming in very fast, and if you can put in an electromagnetic field, you can then take the ionized air and move it and bend it over the wing so it's laminar, and you get perfect flow.
Do they use that, is that used on real jets, or is that something that
I don't know if it's used on jets, but that Dr.
Just looking
Physics,
for somebody to build a model based on that.
well, he wanted one of us to build a model, and I was going to do it, but I had other things to do. Any other questions?
Let's maybe hold off questions. Let's keep.
All right, let's keep going. You can create your own scenery with World Maker. There is scenery when you buy the flight simulator. There are also planes, stock planes that come in there. You can fly at any time of the day or night, at any time of the year. And you can also fly in a full range of weather conditions, being wind, vertical downdrafts or updrafts, fog, rain, the whole gamut of weather conditions. Next. Sorry to take so long.
Here is next, but it's not next there. Why is that?
Yeah, Mac, resume slideshow.
Exactly. Okay.
There we go. Here is XPlane aircraft and the manufacturers of these aircraft. So here are the different types of aircraft we have, our commercial passenger and cargo aircraft. And essentially that's covered by Airbus, Boeing, Bombardier, Canadair, de Havilland of Canada, and Embraer. There are others too. I mean, there's a lot. These are some of the ones that I've worked on. There are business jet and turboprop aircraft in Cessna, Piper, Pilatus, and Gulfstream. There are military jet and turboprop aircraft being Boeing, Lockheed Martin, and British Aerospace. There's general aviation with Cessna, Piper, Cirrus, BB, which I have a model of. I'm going to demonstrate to you tonight what I've done with it, and Beechcraft. It's probably the world's smallest jet. There's also rotary wing aircraft, helicopters from Bell, Sikorsky, and Robinson. Any questions? So all of these I've worked on. There are aircraft, stock aircraft. There's aircraft that you can download from a website. There are literally 3,000 to 4,000 of them that are both freeware and payware. The payware will blow your mind because it looks so real and it performs as well as the real aircraft. And actually, they're not that expensive to purchase either. Next. All right, gliders and sailplanes. These, let's see which one here. I believe these two were stock. This one I downloaded, one of the freeware ones. You'll see the Alexander Schleicher with the ASG 29E. That particular model has, it's like 21 or 22 meters long. And this one is, has a propeller with a motor that is hidden behind the pilots in the fuselage, and the doors that cover it have solar cells. So when you move it's a 3D cockpit. When you move these controls, these open and the motor comes up and it goes up high enough, and then they have a propeller. There are also two more that you can use. Next. Okay, aerobatic. We also have aerobatic and racing aircraft. The three that I've worked on are the Extra aircraft, Extra 300L. Very nice aircraft. They use it for aerobatics and also for the Red Bull air races, which I've actually done virtually. Extreme Air makes the S-Bach 300. They're both from Germany. And BD Aircraft, I believe, was made here in America. And it's the BD-5J, which I will demonstrate tonight. As a matter of fact, maybe one of you would like to fly it. It's actually an aircraft that I downloaded off the website I told you that had about 3,000 to 4,000 aircraft. I made some changes to the CG because when you went to do a roll, you would do, you know, like a well, yeah, I'll do a barrel roll. So by moving the CG, I'm able, when I do the roll this way, it just spins like this real fast. Snap roll, yeah. Okay, for racing, this is the Formula One cassette racer that was used at, actually all these two were used at the Reno Air Races. A friend of mine actually owns this aircraft, and he's the 2015 World's Champion for Formula One air racing. He flies a composite structured aircraft, but most of the Formula One racers are a cassette racer or a version thereof. The P-51 Mustang, he has this one called Precious Metal, and I have that, and I'll show you how it works, and maybe one of you can fly it too. X-Core Aerospace is in the Mojave Desert. It's close to Scale Composites, very close. And they make small rocket motors. And they made the Easy rocket, which is a Burt Rutan design, the Easy. And it's a long wing with rudders on the wingtips, and it's swept. And then they have a canard wing. It was straight, but when you're going really fast, you want the wing and the canard swept. And I'll demonstrate this one too. Next, please. Any questions? All right, last one. Here are the four main things, main areas that you can go to, but the primary one is XPlane, x-plane.com. You can download for free a demo. It's good for 15 minutes of control. It costs
$59.99.
Well, that's for the global version. They also have a regional version, which is North America. And that one's like $34 or $35, which is a lot less. And then if you want the extra, you know, the global scenery, it'll be another $30 or $35, about $30, which I did. Or you can buy it all for $60, the entire world, all the terrain. And they used the space shuttle had stereo radar antennas. And as they were orbiting the Earth, they beamed down stereo radar signals on the returns back to the antennas, they saved it, and then NASA generated a terrain map of entire world, essentially the entire world, up to a certain northern and southern latitudes that most pilots don't go well to the North Pole or the South Pole. For this, you'll need either a desktop. Let me go back. This is a multi-platform flight simulator. If you have a Mac, Windows, or a Linux machine, this will work. If you have a desktop or laptop, it will work. XPlane, the developer, also made it for tablets and for smartphones, Android and Apple. So you can go to the Apple Store or to Google Store, and you can actually put it. But those, for the tablets and smartphones, you just don't have the ability to have all the controls. I mean, it does fly, but it's kind of a reduced control set. So you really want either a laptop or a desktop. Let's see what else. They have full support if you purchase it, full support, and then there's me if you guys buy one. You know, if you have any questions, let me know. To get free aircraft or payware, and payware is exceptional. You can get this at xplane.org. They have a forum. If you have any questions, or if you want to learn something about XPlane or anything, you go here. This is the mother of all XPlane. When I joined, in 2001, I flew XPlane for 1 year. Then I joined a virtual airline. A virtual airline has an organization just like the real commercial carriers, and you fly for a minimum of 2 flights in a month, and then that keeps you active. And the virtual airlines have a variety of different aircraft, but I wasn't really happy with the first one, so I went to a second virtual airline, which was called California Airlines. And I flew the first plane that they had was the Boeing 737, the most widely used plane in essentially the world. And it just didn't feel right, just moving on the ground and landing and takeoff. So I talked to the owner, and the owner was building these aircraft. And I said, you know what we need here is a research and development group or team that can actually update these aircraft and build new aircraft. And that's what we did for, let's see, 8 or 9 years. We were doing that. We had maybe 15 to 20 people. Some would specialize in the flight model, some would specialize in the 3D modeling, some would specialize in the painting. So we were all specialists that worked together as a team to make essentially, I think it was 50 different aircraft, different types of mention. So the owner of the first one started a second virtual airline called Alliance-Airways.net. He asked if I'd move over, which I did. So now he's so busy. He's a biology teacher. He has a PPL, a private pilot's license. He's actually working back with the second airline, California Airlines. So he asked me to step up and be the R&D aircraft director. So essentially I have 60 aircraft that I have to update and add new aircraft when the founders, the owners, they have 3 owners of this. So essentially, and then we have schedules, we have routes. The biggest thing I can tell you guys, if you're going to get XPlane, go to a virtual airline. They will teach you how to fly. If you have any questions at all, either California Airlines or Alliance Airways, they'll teach you how to fly both VFR, IFR, type of flights into essentially bad weather, IFR. And there are scheduled flights, there are charter flights, which means you can go from any airport to any other airport in the world based on your payload of either passengers or cargo. We have both. Essentially, everything I've shown you in the back is what is at Alliance Airways. So, based on all this, I've did some canned videos. I'll keep it short so that some of you can actually fly. I have a joystick here, so I'll teach you real quick if you want to fly one of these planes. That's
Okay.
it.
Let's do it. So this is the kind of the end of the formal part of the talk, and now we can gather around